Now it's your turn to solve an equation using factoring and the zero product principle. Stop this video, take a moment to write out your answer to this problem in your lecture outline packet, and then turn the video back on to check your answer. The equation that we're given here is negative x squared plus 11x minus 18 equals 0. So we'll start by writing that out. And we'll note that since it's already equal to 0, we'll simply need to factor that left-hand side. Now, negative x squared plus 11x minus 18. That negative x squared is critical here because it has a coefficient that isn't 1. Its coefficient is actually negative 1. So as our very first step, we'll want to factor out that coefficient of negative 1, which in general we can just put as a negative sign outside parentheses. So we'll factor out a negative, and that'll leave us with x squared. And since we're factoring out a negative, the sign on every term is going to change. So we'll have a negative out front, and then inside parentheses we'll have x squared minus 11x plus 18. Now, what we have left to factor is x squared minus 11x plus 18. So we need two numbers whose product is 18 and whose sum is negative 11. So we can make a quick table of factor pairs of 18, and we know that we need a sum of negative 11. So if we need the product to be positive and the sum to be negative, then both of these numbers need to be negative. So the factor pairs we'll consider are negative 1 and negative 18, and that has a sum of negative 19. We'll also look at negative 2 and negative 9, and that gives us a sum of negative 11. So at this point we're done. Applying that here, we'll then have the opposite. We're going to go and factor this x squared minus 11x plus 18 further. So we still have that negative out front. And then inside here, we're going to factor x squared minus 11x plus 18 into x minus 2 times x minus 9. And again, we can directly apply that because we have a trinomial there and the leading coefficient is 1. If we wanted to check that, x squared minus 11x plus 18 factored into x minus 2 times x minus 9, we could expand just that x minus 2 times x minus 9 and get x squared minus 2x minus 9x plus 18, and we'd see that that was correct. At this point, we have the opposite of, and then the factor x minus 2 in parentheses times the factor x minus 9 in parentheses. So at this point, we're ready to use the zero product principle. The negative out front is a factor of negative 1, and it doesn't have a variable in it, so it won't result in a solution. So from there, we won't worry about that factor of negative 1, but x minus 2, if that was 0, then we would get a solution. So we'll have x minus 2 equal to 0, or x minus 9 equal to 0. Solving that first equation, x minus 2 equals 0, we'll get that x is 2, so x equals 2. And solving x minus 9 equals 0, we'll find that x equals 9. So the two proposed solutions are 2 and 9. We'll go through and check each of those. And we'll do that by replacing the variable in that original equation with that proposed solution. So let's check x equals 2. We'll go to that original equation and we'll replace every instance of x with 2. So we have negative x squared plus 11x minus 18 equal to 0. So we're going to have then negative of 2 squared plus 11 times 2 minus 18. And we're checking, does that equal 0? The negative of 2 squared is going to be negative 4, and then we're adding 11 times 2, so we're adding 22, subtracting 18, and we can see pretty quickly that negative 4 plus 22 minus 18 does indeed equal 0, so that solution checks. Next, we'll check our proposed solution of 9, so we'll replace every instance of x with 9. So now, for this instance, we'll have the opposite of 9 squared, so the negative of 9 squared, plus 11 times 9, minus 18, and we're checking, does that equal 0? So the opposite of 9 squared will be negative 81, and then we're adding 99 and subtracting 18, and we're checking, does that equal 0? So I can almost see if I take negative 81 and I add 99, I'll get 18, then I'm subtracting 18, and indeed that equals 0. So both of these solutions checked, and now I can state that the solution set is the set containing the numbers 2 and 9, and so I'll write that with curly braces and 2 comma 9 inside those curly braces.